In late October, NASA headquarters directed Marshall to terminate the Saturn I program following conclusion of the 10-flight vehicle R&D program. This action eliminated 4 operational vehicles plus 2 spare vehicles, deleting all Saturn I manned flights. Prime hardware contracts for operational vehicles have been canceled. Hardware on hand will be used when possible on the boosters for SA-201 and 202. NASA headquarters also approved launching of the remaining Saturn I vehicles from Launch Complex 37B and modifying Launch Complex 34 for initial Saturn IB launches. At Cape Kennedy, early in October, the S-45 stage was mated with the previously erected SA-5 booster, the instrument unit, and the payload. Pre-launch checkout of the vehicle continued as scheduled until November, when an explosion in Launch Complex 37B's gaseous hydrogen vent line caused a delay of 1 week. Other technical problems encountered during testing were quickly resolved until cracked sleeves were discovered in the S-1 stage high-pressure pneumatic lines. These sleeves, which had cracked because of stress corrosion, had to be replaced. This requirement forced rescheduling the launch from late December until early 1964. To prevent reoccurrence of the problem, MSFC issued new specifications on heat treating and began installing new sleeves on S-15 and all subsequent S-1 stages. Marshall and Douglas have taken advantage of the delay to perform additional testing on S-45's cold helium sphere mountings. Following completion of these tests and the critical tubing replacements, the simulated flight test will be repeated and the vehicle launched. At Marshall, the flow of subsequent S-1 stages continued, even though work on each stage is being interrupted to allow for tubing replacement. Booster post-static checkout was completed for the 6th Saturn flight vehicle, SA-6, during November. Following completion of preparation for shipment, the stage will be barged to Cape Kennedy early in the next quarter. SA-6 will be the first vehicle to have an Apollo boilerplate spacecraft as payload. Meanwhile, the booster for the 7th flight vehicle, SA-7, underwent 2 successful firings at Marshall's test laboratory during October, one for 35 seconds, the other for 145 seconds. Stage post-static checkout, delayed temporarily to allow for tubing modification, is expected to be completed during February. Assembly of the booster for the 8th flight vehicle, SA-9, was completed in October and pre-static checkout started. Static firing of the stage is presently scheduled for late next quarter. At Michoud on October 27th, Chrysler began checkout of the first industry-produced Saturn I booster, S-18. The functional checkout began in November. Mechanical systems were the first to be checked out. Pneumatic pressure lines and connections were checked for leaks. Checkout completion is presently scheduled for March. In April, the stage will be shipped to Marshall for static testing. Assembly of S-110 by Chrysler continued at Michoud during this quarter. Assembly completion and start of checkout is scheduled for April 1964. Preparation of H-1 engines for the stage continued on schedule. 2 engines originally intended for S-1-111 will be used to replace S-110 engines that developed thrust chamber leaks. Early in October, the Douglas Aircraft Company installed S-46 in SACTO Test Stand 2B and began preparations for acceptance testing. On November 22nd, a successful static firing was conducted for 460 seconds as planned. Post-static checkout was completed in December. Presently, necessary modifications are being performed, including Moog engine actuator retrofit. The stage is scheduled for shipment to AMR during February. Also, at Santa Monica, final assembly of S-47 by Douglas was completed in November. Checkout of the stage in the new vertical checkout facility is nearing completion. S-47 is scheduled to arrive at SACTO for acceptance testing early in February and will be installed in the stand a few days later. The S49 stage, located in Douglas's assembly facility, is approximately 20% complete. Stage completion remains dependent upon the S47 progress. Meanwhile, S48 was moved from the insulation installation room to the assembly area where miscellaneous pickup work was completed. Parts shortages which delayed moving the stage to the hydrostatic tower have been negated and the stage erected in the tower. During the latter portion of the quarter, installation of S410 stage insulation at Santa Monica started immediately after completion of leak tests and tank calibration. The stage is scheduled to be removed from the insulation installation room and be installed in the hydrostatic tower for additional leak checks in late January. At Sacramento, Douglas buildup of the all-systems S4 vehicle continued during this quarter. Static firings are scheduled to start in late January. At Marshall, completion of functional checkout for SIU-6 was rescheduled for January 1964 to allow checkout of engineering changes incorporated during December. SIU-6 and S-16 will be shipped to Cape Kennedy in February. Marshall assembly of the instrument unit for SA-7 is complete, and final checkout is presently scheduled to begin at MSFC on February 10, 1964. Structural fabrication of SIU-9 will be completed in January 1964 at Marshall's Manufacturing Engineering Laboratory. The structure will then be stored until start of assembly March 2, 1964. At Marshall's Test Laboratory, dynamic testing for the SA-6 and 7 configuration using the Saturn dynamic vehicle and the Apollo boilerplate was successfully completed during this quarter. Later in February, MSFC has scheduled dynamic testing for the SA-9 and 8 configuration. SA-9 and 8 will carry micrometeoroid detection payloads. Preparations are underway at the dynamic test stand and are proceeding satisfactorily. During this same period, the S4 stage Moog actuator systems were tested by gimbaling the RL-10 engines. Marshall approved Chrysler designs for the S1B Spider beam and completed the 50% design review of the 60-degree fairing and the conceptual design review of the GOX line and diffuser. The design associated with elements of the tail section is now approximately 60% complete. On November 8th, MSFC authorized Rocketdyne to continue with design, development, and testing required to uprate the H-1 engine from 188,000 pounds of thrust to 200,000 pounds of thrust. The first production engines are scheduled to be acceptance tested in the next quarter. At Santa Monica, Douglas finished welding studs to the hydrogen forward dome of the S4B hydrostatic test stage. Work on the dynamics test stage included bonding the honeycomb core to aft common dome, welding of flanges and elbows to the aft LOX dome subfittings, and seal welding between the T-rings. Also, the liquid hydrogen cylinder skins for this stage were milled for forming and welding, but one skin was rejected due to several cracks. A replacement has been scheduled for the skin mill. Meanwhile, work progressed on the all-systems test stage. The attach rings for the common domes were completed, and welding operations are underway. The common bulkhead is being welded for the first flight stage, S4B1. At Douglas's Beta Complex at Sacramento, static firing site for S4B, the superstructure for the battleship test stand, Beta 1, was completed. Following final assembly and installation of insulation, the battleship tank was placed in the Beta 1 stand December 18th. The Beta Complex blockhouse is nearing completion. At Beta 3, the all-systems test stand superstructure and propellant tanks were also nearly completed. Rocketdyne has completed fabrication of the first J2 production engine, originally designed for cold flow testing. Delivery was made to Santa Monica in November. After inspection and checkout, the engine will be used in the Engineering Development Systems Integration Laboratory. Activity at Douglas's S4B mock-up area at Santa Monica included electrical component installation in the aft thrust structure, aft skirt electrical paneling installation, Customer Connect Panels installation, DAC's mating area to the J2 engine, work on the instrumentation probe, and forward dome instrumentation wiring. The Delta II test stand at Santa Susana, which affords a 500-second run capability for the J2 engine, was activated November 9th, and engine testing at both positions began late this quarter. A major milestone in the J2 engine program was achieved late in the quarter with 2 successful full-duration hot firings of the engine, one for a period of 508 seconds, the other for 510 seconds.